asking questions, and defining problems. A practice of science is to ask and refine questions that lead to descriptions and explanations of how the natural and design world works, and which can be empirically tested. Asking questions is the first step in science and engineering. In science, we ask questions to explain phenomenon, and in engineering, we ask questions to define problems that will lead to design solutions that will fulfill human needs. In science, we start by asking questions and we use inquiry to explain them. Scientific questions are distinguished from other types of questions in that the answers lie in explanations supported by empirical evidence, including evidence gathered by others or through investigation. While science begins with questions, engineering begins with defining a problem to solve. However, engineering may also involve asking questions to define a problem, such as what is the need or desire that underlies the problem? What are the criteria for a successful solution? Other questions arise from generating ideas or testing possible solutions, like what are the possible trade offs? What evidence is necessary to determine which solution is best? What can we do as teachers? Develop strategies that can help students come up with questions on their own. Teach them to refine the questions and recognize which ones are good and really science ones, and which are questions that we can answer through design and science lab. Developing and using models. A practice of both science and engineering is to use and construct models as helpful tools for representing ideas and explanations. Models are physical, conceptual, clear, external, and shared by everyone. They are an analogy for how phenomenon and designs work. They can be structural, behavioral, or functional. Models include diagrams, physical replicas, mathematical representations, analogies, and computer simulations. In science, models are used to represent a system or part of a system under study, to help in the development of questions and explanations, to generate data that can be used to make predictions, and to communicate ideas to others. Students can be expected to evaluate and refine models through an iterative cycle of comparing their predictions with the real world and then adjusting them to gain insights into the phenomenon being modeled. Models are based upon evidence. When new evidence is uncovered, the models can't explain, models are modified. In engineering, models may be used to analyze a system to see where or under what conditions flaws might develop, or to test possible solutions to a problem. Models can also be used to visualize and refine a design, to communicate a design's features to others, and as prototypes for testing design performance. What can teachers do? You can help students develop models by drawing. You can give demonstrations and have students draw parts of it as well. Planning and carrying out investigations. Scientific investigations may be done to describe a phenomenon or to test a theory or model for how the world works. The purpose of engineering investigations might be to find out how to fix or improve the functioning of a technological system, or to compare different solutions to see which best solves the problem. Whether students are doing science or engineering, it is always important for them to state the goals of an investigation, predict outcomes, and plan a course of action that will provide the best evidence to support their conclusions. Students should design investigations that generate data to provide evidence to support claims they make about phenomena. Students should have the opportunities to plan and carry out several different kinds of investigations during their K through 12 years. At all levels, they should engage in investigations that range from those structured by their teacher in order to expose an issue or question that they would have been unlikely to explore on their own, to those that emerge from their own student questions. Analyzing and interpreting data. Once collected, data must be presented in a format that can reveal any patterns and relationships and that allows results to be communicated to others. Because raw data have little meaning, a major practice of scientists is to organize and interpret data through tables, graphs, or statistical analysis. This analysis can bring out the meaning of their data and their relevance so that they may be used as evidence. Engineers, too, make decisions based on evidence that a given design will work. They rarely rely on trial and error. Engineers often analyze the design by creating a model or prototype and collecting extensive data on how it performs, including under extreme conditions. Analysis of this kind of data not only informs design decisions and enable the prediction or assessment of performance, but also help define or clarify problems, determine cost feasibility, evaluate alternatives, and investigate failures. So, what can teachers do? Teachers can provide notebooks that help them gather or collect data. It can include drawings, numbers, words. Tables and graphing are a good way to organize data, which will help with analyzing it.